Imagine peeling back the skin of a planet, layer by layer, cloud by cloud, stripping away everything visible to the naked eye until you reach the hidden machinery churning underneath. That's exactly what scientists just did, not with a scalpel, but with two of the most powerful telescopes humanity has ever built. And the patient, Saturn, the most iconic, most photogenic, most mysterious world in our solar system. What they found didn't just update our understanding of Saturn. It may reshape how we think about planets across the entire galaxy. On March 25, 2026, NASA and ESA released what they're calling the most comprehensive view of Saturn ever assembled. By combining infrared observations from the James Webb Space Telescope with visible light imagery from the Hubble Space Telescope, astronomers produced new views of Saturn revealing atmospheric bands, storms, and brilliantly reflective rings. This wasn't a single snapshot. It was two telescopes, launched 31 years apart, working in concert like instruments in an orchestra, each playing a frequency the other cannot reach. Hubble captured crisp, long-term visible light views of Saturn's cloud bands and atmospheric changes, while Webb peered deeper into the planet's atmosphere in infrared, revealing heat patterns and structures hidden beneath the upper cloud layers. The result is something scientists have been dreaming of for decades, a three-dimensional portrait of a gas giant rendered in light we've never used together before. Here's the core scientific breakthrough, and it's as elegant as it is profound. Together, scientists can effectively slice through Saturn's atmosphere at multiple altitudes, like peeling back the layers of an onion. Each telescope tells a different part of Saturn's story, and the observations together help researchers understand how Saturn's atmosphere works as a connected three-dimensional system. Think about what that means. For generations, we've been looking at Saturn's surface, the pale yellows, the soft amber banding, the rings catching sunlight, but we never truly saw inside it. Now we can. Webb's infrared eye doesn't just photograph the top of the atmosphere, it cuts through, detecting chemicals and cloud formations at depths no visible light telescope can reach. Webb looked at the planet's infrared light to peer deeper into the layers of its atmosphere, and what it found down there is extraordinary. Saturn has never been a calm world, but these new images reveal just how dramatic its internal weather truly is. In the Webb image, a long-lived jet stream known as the ribbon wave meanders across the northern mid-latitudes, influenced by otherwise undetectable atmospheric waves. Just below that, a small spot represents a lingering remnant from the great springtime storm of 2011 to 2012. Let that sink in. A storm that erupted over a decade ago, so violent it wrapped around the entire planet, left a scar that Webb can still detect today. All these features are shaped by powerful winds and waves beneath the visible cloud deck, making Saturn a natural laboratory for studying fluid dynamics under extreme conditions. Saturn isn't just a pretty picture, it's a pressure cooker, a fluid dynamics puzzle running at planetary scale, and we're finally getting the instruments capable of reading it. Now for the image that's going to dominate your social feeds. When Webb turned its infrared eye on Saturn's rings, something stunning happened. In the infrared view, Saturn's rings transformed into glowing blue because they are made of highly reflective water ice. The rings we've always seen as white or golden? In infrared, they blaze electric blue, blindingly bright against the darker body of the planet. There are also subtle ring features such as spokes and structure in the B ring, the thick central region, that appear differently between the two observatories. The F ring, the outermost ring, looks thin and crisp in the Webb image, while it only slightly glows in the Hubble image. These aren't cosmetic differences. The way light interacts with ring material at different wavelengths tells us about particle size, composition, and the ongoing physics of ring erosion. Saturn's rings, scientists now believe, are slowly disappearing, and Webb is helping us understand exactly how fast and why. Perhaps the most mysterious discovery in this new dataset sits at Saturn's poles. Saturn's poles appear distinctly gray-green, indicating light emitting at wavelengths around 4.3 microns. This feature could come from a layer of high-altitude aerosols in Saturn's atmosphere that scatters light differently at those latitudes. Another possible explanation is auroral activity, as charged molecules interacting with the planet's magnetic field can produce glowing emissions near the poles. auroras, on Saturn, the same physical process that paints our Arctic skies green and violet, playing out on a world over 1 billion kilometers away, at temperatures that would freeze us in seconds. The confirmation of polar auroral activity is more than beautiful. It tells us about the strength and structure of Saturn's magnetic field, and it opens new questions about how that field interacts with the solar wind and the planet's own moons. So why does any of this matter beyond Saturn itself? Because Saturn is a template, Webb now adds powerful infrared capabilities to this ongoing record, extending what researchers can measure about Saturn's atmospheric structure and dynamic processes. Every detail we decode about how Saturn's atmosphere is layered, how its storms evolve, how its magnetic field drives polar emissions, all of that becomes a decoder ring for studying gas giant exoplanets orbiting distant stars. We've now confirmed thousands of exoplanets, and a significant fraction of them are gas giants. But we've never had the tools to truly understand what's happening inside them. Webb changed that. Saturn is essentially the closest, best-lit laboratory we have for gas giant physics. Every storm mapped, every atmospheric layer separated, every aurora cataloged. Here is a data point we can export to those distant worlds. Astronomers can see through Saturn's atmosphere as if peeling back the layers of an onion to observe from the upper atmosphere down to its deeper roiling secrets. And as Saturn's North Pole enters its long seasonal winter darkness, we probably won't see the hexagonal polar storm so clearly again until the 2040s. Scientists know this window is precious. 2 telescopes, 1 planet, an infinite set of questions answered, and an even larger set now opened. This is what it looks like when humanity actually looks up, not just with our eyes, but with every photon of light that existence has to offer. Saturn has been out there for 4.5 billion years. It waited a long time for us to see it clearly. We finally have. If you like the video, share it and don't forget to subscribe. Cosmic Secrets 108, turn on notifications. See you in the next video.